sharks. That's coming up later on. Carlo, are you ready for that one?
Less sure about that.
So this year, we had the hottest day on record. 2024 is going to be the hottest year on record, and we've just had the hottest decade on record. As a climate scientist, but also a European citizen, how does it make you feel?
Well, it's one of these things that you really see this tendency toward warmer and warmer temperature, and it's relentless. You continue, and in a sense, as a director of the Climate Change Service, we keep providing this information of the record-breaking day, record-breaking temperature of the month, of the year, and in a sense, it's not particularly relaxing as a job. It's always this warning, this alarm.
Tension.
Yeah, there is always this tension, but at the same time, the fundamental physics behind that is very clear. So we cannot expect anything different. The concentration of greenhouse gases is going up, and so is the temperature. So we are bound to see more and more of these extremes that we've seen this year.
I was going to ask you actually whether or not what we see is exactly what you were expecting, or is the climate and the weather becoming harder and harder to predict?
Well, there's been some debate recently about that point, because clearly, as scientists, we'd like to look at the things that we didn't get right. Science is driven by ignorance, by surprises.
Yeah, so you're looking for the questions and the holes all the time.
And you think, well, actually, we didn't get it fully right. These things, this detail, this big jump in temperature that we've seen last year, it wasn't exactly how we predicted. And so within the community, there is a lot of discussion on the thing we haven't understood, which I think is right, is what we should be doing. And I don't think we focus necessarily enough on the many things we got right. So if you look back 20 years at what was said at the beginning of this century about the massive heat wave of 2003 and the extra death in France and so on, well, at that time, I remember because I was already doing this job, at that time we were saying, well, in the 2020s, this sort of event will become much more common. And
I remember you saying that. You're saying this is going to keep happening, and now it keeps happening.
Exactly. And in a sense, I feel as a society, we were not able to take full advantage of that information. I mean, it's not perfect. What we have seen last year is at the edge of what we thought was possible then.
Right.
Still.
At the upper edge.
At the upper edge, indeed. Still, the big picture was correctly captured. The temperature has gone up for the last 2 decades, and the temperature we are seeing now are not too dissimilar from those we predicted or projected 20 years ago.
Now, for those who don't know the Copernicus Climate Change Service, search for them online. You'll find they give monthly bulletins, which I present in our Climate Now program on Euronews, and it's free for anybody to have a look at. You don't need to sign up, and you can read information, understand more about what's happening, look at the science and the data, and kind of get a real idea, particularly on European scale, what's happening, because you know what the weather was like where you live last month, but you don't know what happened 500 or 600 kilometers away. Actually, and also thanks for sending in questions. I've got one here from Davide, which kind of is related, I think, to what we were just talking about there already. He's saying, do scientists get climate anxiety?
Well, at least the children of scientists, for sure, I can tell you firsthand. Right. I guess many of us grew a bit used to this news.
This hottest, warmest.
So in a sense, is what we expect. Nevertheless, there is something in the back of our mind that it doesn't sound right, doesn't feel right, doesn't make you uncomfortable. You know, being always the provider of bad news. It's not necessarily something.
It's not. And I'm not allowed to talk about it around the dinner table at my house. Davide, also his follow-up question was, why is it so difficult to convince people that this is happening? And actually, I was talking to the mayor of Zagreb last week at COP in Baku, and he was saying that he encounters climate skepticism in Zagreb when he's talking to his constituents. Do you encounter that?
Oh yeah, all the time, and actually it's probably on the rise. But in a sense, if you allow me, I would like to defend skepticism, because that's the driver of science. You know, we don't trust each other just because we are, known people or is a very well-known scientist. It's all about fact. It's all about evidence. And in a sense, going back to what you were saying about the Climate Change Service, I think one of the strengths of what we do is that everything we do is open and free. Anyone can look at the raw data, analyze the raw data, and reach their own conclusion.
You want to make your own graph? You can make your own graph.
Absolutely. Yeah. And actually, even the piece of code that we use to do the graphs is available. And someone online said, well, that you should have done it differently. I said, well, you could do it differently, and they did it. So in a sense, I do think that it's a very good habit, and it's a very scientific habit to be skeptical. Right? And so I would like to take it back. I don't think that skeptic is a bad word. I think it's something we should be all proud of. Yeah. The question is that while we are all entitled to our own opinion and on theory, I don't think we are entitled of having our own facts. And so in a sense, for me, the key element is to recognize that there are certain things that are just happening.
Yeah.
right? And that's the starting point. Then we can discuss what is the best course of action given this information.
Absolutely.
But the starting point should be the observation and the evidence.
Now, when it comes to what is actually happening and looking at what's actually happening, we've had an awful lot of rain and we've had this terrible flooding in Valencia. A lot of people are saying, why is it raining so much? But first off, we saw a year's worth of rain there in Valencia in some places. Did climate change contribute to that? Is that a climate change impact? Can we definitively say that?
Well, this kind of question, I always answer yes and no, right? And I think I will answer many of your questions with yes and no, because there is a no part to it. The DANA, which is the name for this event, this low pressure system in the upper air with cold air aloft. Well, this event have always been there in eastern Spain, in eastern Iberia. And these have been the driver of many of the catastrophic floods that have affected Valencia and Catalonia and other parts of the Mediterranean. So in that sense, climate change has nothing to do with that. That's
because
already...
I was reading about it even in the time of Franco. They were doing big works to get ready for this, to prepare, to make
57 in Valencia, major flood, 62 in the hometown of my wife, in Terrassa, near Barcelona. Many people displaced, many people killed. So these kind of events are not uncommon, are the main driver of flooding in that region. What is uncommon, as you were saying, is the amount of precipitation that fell in the space of a few hours. And so in that sense, you can say, well, is there a climate signal in that? And probably there is. We have seen this summer over the Mediterranean the warmest temperature of the ocean ever recorded for the Mediterranean as a basin. Yeah. That was in the 13th of August, we reached 28.4 degrees. That's really much warmer than before. And this extra heat means extra energy for these storms, means extra water vapor that can be held in the air, which means extra precipitation. And what we have seen in Valencia actually is not unique to Valencia or to Spain or to the Mediterranean. We have seen an increase in the most intense precipitation in all continents, not just in Europe. So we are bound to see more.
We're shocked by that. And when I was at COP29 in Baku last week, all the Europeans were talking about that, and people from other continents too, making reference to Valencia. But let's have a look at the data then from Copernicus on precipitation anomaly for October 2024. So this is the kind of information you can see online. So Carlo, talk us through what we can see there. Is the Valencia signal from that rain clear there?
Well, what we're looking here is a monthly average. So you're looking at the whole month of October. And even so, you don't necessarily see specific event. And even so, if you look on the south or eastern part of the Iberia, you see these darker blue spots. Yep. These are region, Valencia is more or less here, where you see this darker blue area. So even on the monthly mean, this comes up, because in some stations, as you were saying, we have seen 700 millimeters in a day or in the space of a few hours. You also see a large signal of intense precipitation over northern Italy. And even there, we've seen flooding and problems in southern France, northern Europe as well. But what I found interesting of these maps is their richness. It's not just one message. It's not we are saying, oh, it's flooding everywhere. No. It's the fact that you have some region where actually it was colder, it was drier, it was windier, it was.
I often think, you look up over here over Russia and Ukraine, etc., drier. I mean, we've had a lot of drier down here as well over the last this year at least in that part of Europe. Let's switch over to the map that's related to the annual precipitation anomaly for 2023, because climate data is often about what's happening longer term. Yeah. Can you talk us through this one? Because look, it's dry down here in Spain. What's going on?
Yes, and actually this is the richness I was talking about. If you look at the climatological signal, there is a clear drying signal over southern part of Europe, in particular the Mediterranean. We have seen over Iberia once more and part of Italy, especially in the year before and in 2023, this large drought that broke.
Yeah, we reported on that.
Remember
the empty reservoirs, all that.
Exactly, with the church in the middle of the reservoir. Well, this is the signal that we see there. So we see this general decline in precipitation across the Mediterranean. I mean, it's slow but steady, because on the one hand, the precipitation is declining, on the other, the evaporation is increasing, so the water balance at the surface is very negative. On the other hand, because of the rising temperature, this means that the air can hold more moisture, more water vapor, and this means that the intensity of precipitation actually is also increasing. So you have these two phases.
So it doesn't mean the air is always more humid, it means it just can hold more water vapor.
That's correct.
It's not that it's not always doing it.
No, it's the maximum capacity. So there's this very known relationship, Clausius-Clapeyron, that often is cited by climate scientists, and he tells us that every degrees of warming, the maximum moisture content in the atmosphere, the water vapor in the atmosphere, goes up by 7%. Given that Europe has gone up by more than 2 degrees, you can imagine that some of these events may actually have 14% more.
14% more,
Right.
and hence enough to tip over to the floods that we might get in Valencia, where the system was set up for a particular level of possible flooding, and obviously it went over that, right?
Yeah, and I guess this is a very interesting reflection, because in a sense is when you see this really large event, 700 millimeters in a few hours, well, you can discuss on how much a purely engineering solution can be the solution of the problem, because it's something immense. I mean, we have seen it in you remember last year with Storm Dennis in Greece. We got a similar situation northeast of Athens. We got 800 millimeters in the space of 2 days.
Yeah, the numbers were
Libya.
amazing. Yeah, in Libya it was shocking.
Shocking.
Yeah.
And in a sense, I think that we need to increase our preparedness for this event and our ability to warn the population of
But it also was an awful lot wetter up in Northern Europe. I mean, I'm from here, and I live down here. It certainly felt a lot wetter this year as well. Yeah. And I'm guessing that's hitting...
Especially in summer, wasn't it?
Yeah. I mean, we're used to rain, but like extra rain, agricultural production, those sorts of things. Are we seeing changes in the trends there as well because of these precipitation patterns, or is it too early to say anything about that?
Well, they are partnered everywhere. I think that is a systemic change. So it's not something that affects only our health or our risk. Affects every part of society. It affects the crop that we can or cannot grow anymore in Europe. Yeah. It affects our technique or modus operandi for water management or hydropower. It affects our ability to generate electricity, to transport goods across the country. So we need to approach the challenge of adaptation and mitigation with that in mind. It's a systemic transformation of the entirety of our society. And we do know something about what's happening, and we should be able to use it better than we have done so far. So just talking about crop, you were talking about crops failure in some cases because of the extra moisture potentially. But there is also the flip side of the story. There is a farmer in Sicily who has tried to grow coffee for 20 years, and eventually, a couple of years ago, managed to get his first harvest. Right. The temperature was so high, right?
Wow.
So I don't necessarily think it's one thing.
No, but there are changes. You say systemic changes.
Systemic changes.
Big changes. Also, as we said at the beginning, 2024 is on track to be the hottest year on record. And I want to talk about heat. Is something we all live through in the summer. At the moment, you've probably forgotten what it's like to be warm. It's cold in Northern Europe. It's cold here in Brussels. It's going to be cold in lots of bits of Europe for the next few days. But remember the heat of the summer. And actually, I've just got a question come in from Natalia, who's saying, should we say global warming or climate change, actually, when we're talking about this stuff?
Well, in a sense, I think both definitions are correct. The entire climate is warming up, but is, in a sense, this climate change, which has been used to maybe remove this sense of warming from the conversation. So maybe there is a political undertone to the switch of the language.
Which do you prefer?
Well, I like the idea of climate change because for me, it indicates that it's not just temperature, it's the entire system that is changing. Yeah. But at the same time, I know that some political commentators have seen into it a way of removing this sense of warming.
And hence urgency, perhaps,
exactly.
You might have
so
associated
both things are true.
Interesting. Okay, so I'm fine to use global warming. Let's have a look at the temperature anomaly map for 2024 compared to previous years. Again, this is a good way of looking at things because we can have a look at what was the previous warmest year on record, which is this orange one, that's 2023, and then what's happening with 2024.
Yeah, so all these gray line you see here, each one of them represent the trajectory in terms of global mean temperature anomaly with respect to pre-industrial of every single year from 1940 to now. As you said...
So I was born in 1972, so I'm sort of down here somewhere. That was about there-ish?
Yeah, probably.
Righto.
We are similar age, so we are more or less here. But in a sense, if you look at 2023 was an extraordinary year, as you remember, has become the warmest on record, and you also see why. I mean, we are talking about surprises.
A huge gap.
Many climate scientists were very surprised by this jump. You see this huge jump with respect to climatology in September. And this was at the very edge of what we thought it was possible. So we closed the year just shy of the 1.5 mark. It was 148 in our data set. And then we started 2024 very, very warm. That's
Yeah.
normal because it was a Nino year. Well, normal. It's still
Yeah.
extraordinary,
But it was
they're
kind of expected.
Yeah, expected because partly also because of El Nino. And since then, we have for the first 6 months, each of these months has been warmer than the correspective month in 2020.
And again, you've got a huge gap between your 2023 and your 2024.
Yeah.
How do you explain that? Is there a natural variation component in there as well?
Well, in a sense, I guess we have to be careful because it's something so recent, and this is among the things we don't know. So we cannot necessarily, I mean, we can come up with plausible hypotheses rather than verifiable facts.
Right.
And plausible hypotheses include the fact that it was a moderate to strong El Nino, the fact that we are close to the solar maximum, so there is more energy coming from the sun than other years, the fact that we had change in legislation that may have altered the amount of aerosol coming from shipping and shipping lane.
Yeah.
This is probably important at the local level, not so important at the global level, but it is another of these possible contributing factors, and there are many others that could have contributed. When we were back in May, June, we were actually expecting the El Nino to make a sharp transition towards La Nina, which is the cold phase, and this would have cooled down the global mean temperature. And also because of that, we were not saying much about 2024 beating the record of 23 because we were expecting...
You were not expecting it.
No. And since then, actually, the transition towards La Nina has not been as strong or as rapid as we were expecting. And so, as you see, in 2024, the temperature have lingered around this 1.5 degrees, slightly above and slightly below. Now, this means that we are, in November, October is behind our back. And, missing a catastrophic event or a major dramatic
cooling was basically going to be warm.
But it needs to go down to 0 for the next 2 months, which has never happened in our history.
No, it's not going to happen.
Then 2024 will become the warmest on record and the first above 1.5.
1.5, good, because the good that you mentioned that, because in fact, Eleanor sent us a question. It's looking increasingly likely that we will not limit warming to 1.5 degrees by 2030. We're talking about the Paris Agreement goal there. Would it be better for leaders to scale down targets for a more realistic goal, or would this be bad for progress? It's a very political question with COP underway.
Well, in a sense, I think it's important to have this benchmark. And the 1.5 is a benchmark, and is a benchmark that is a scientific value, but is also a value that is understood and used by in the political debate. So I don't think we should remove that. I think we should still use it in our negotiation, despite the fact that the path to 1.5 by 2100 is incredibly narrow or nearly impossible now. And
was it 43% reduction by 2030? I think that we need in greenhouse gas emissions. So
and we're not seeing that.
No, we're not seeing that.
And in a sense, this will be in almost basically it's virtually certain 24 will be the first calendar year above 1.5.
Right.
This doesn't mean that we have yet breached the Paris Agreement threshold.
A question from Noah. Thank you, Noah. This is a great question, very direct. When is it going to be too late? Do you have a date?
Yeah, well, in a sense, there is this. I use this Chinese saying because I like it, and I think it gives the urgency of what we might need to do. And when is the best moment to plant a tree? And the answer is yesterday. And when is the next best moment to plant a tree? Well, it's tomorrow, right? So in a sense, if our goal is to keep the temperature below 1.5, as we promised to do in Paris, or below 2, and the best effort to keep it below 1.5, well, then we need to do something, because at the moment we are not on the right track.
Get planting trees, in fact, which takes me through to heat waves, and I wanted to talk about the heat waves that we had in Italy, in the Balkans. Remember what it was like in the summer? Yeah, it's nice when it's warm, but it's horrible when it's 40 odd degrees. And I was just running through some of the things that we saw that happened this summer in Albania. They changed the working hours for civil servants because it was too hot. In Bosnia, some of the power networks were impacted. Traffic lights stopped working. In Bulgaria, they had wildfires. In Sofia, they were distributing water. In Croatia, in Dubrovnik, bars and restaurants closed down in the heat wave in the summer. Greece had its longest heat wave on record, lasting 40 14 days. Minimum temperatures overnight were above 30 degrees for 12 days, which is just horrible. Imagine trying to sleep in that. I was talking to a Greek colleague earlier who's just saying it's like sleeping in an oven. Croatia and Serbia used a record amount of electricity because of the air conditioners that are being used. How are we going to adapt to this? What does it mean for health, for productivity, for the economy, etc.? Because this is now what summers are starting to look like.
Yeah, absolutely. It would have impact on all work of life, all activities we do. But in a sense, this is already affecting us negatively in Europe. If you look at what the Lancet Countdown said last year, over the last 20 years, so since the beginning of this century, heat-related mortality in Europe has gone up by 30%. That's a massive increase. And this has not just affected one country, maybe Greece this summer, actually has affected the entire territory of the EU. So this is a new hazard, and a hazard that maybe we are not even aware of. It's uncomfortable to sleep when you saw it, but it's potentially extremely dangerous, especially if you belong to one of these more at risk, more exposed.
I was going to say, it's very unfair, isn't it? Because there's people who are particularly, there might be because of health problems more at risk, because of their age, where they grew up. I was actually talking to a city councillor from Turku in Finland, not associated with problems of heat, but they've started having problems. They hit 27 degrees, and for them, they started having mortalities because people were not ready for that kind of heat. So what do we do to try and switch our minds around to this? What needs to happen in policy? What do individuals do?
Well, first of all, I think we have to raise awareness. So this is an issue, and is a fundamental issue of our society. This heat wave have increased. We were talking about it in 2003, but if you look at what the IPCC Sixth Assessment Report says about Europe, well, heat waves will become more prevalent, will last for longer, will be more frequent. So in a sense, it's something we know that will happen, and we can prepare for. What does it mean preparing? I mean, the example you made about changing the working hours, well, that's a relatively simple and effective way of reducing our exposure. You can build house differently. You can organize our everyday activities differently. You can organize
like schools and things like that, for
Absolutely.
example?
I mean, there are a number of adaptation. Adaptation has the advantage of being very local, typically.
Yeah.
So mitigation requires the COP agreement requires a multilateral international agreement. Adaptation happens in your backyard. Adaptation happens in your village, in your city.
How are you adapting then in your backyard? What are you doing?
Well, in my backyard, we changed and refurbished the house because we could. And so now there is a big insulation under the roof, and there is a system for heating. The house is nearly passive, but we have a...
And that's an old house.
It's a old house, yes, 150 years old.
Yeah. My house is an old house too. I know. I think my thing is to go and hide in the wine cellar. I'm not going to invite everybody watching to join me for that one. It's nice down there. But no, certainly it's hitting productivity. We see that, and we're reporting that on Climate Now, that workers are facing it. It's hitting the economy. We've had a question from Clara. Some cities, such as Barcelona, now have climate shelters. Do you think that can be a long-term solution? And I think Greece have that too, don't they?
Well, in some cases, I think we need to have solution to reduce the risk of the people living in cities. The cities are particularly hotspot, in this case, literally hotspot for heat waves, because of the built environment generate an environment that per se is warmer than the surrounding countryside. Yeah. So in a sense, knowing that and knowing how much the temperature will go up means that we can redesign the city and ensure that there are shelters so that, movement within city can be done without putting yourself at risk. But it's one of many actions that can be considered to reduce our exposure, because in a sense, ultimately to reduce the risk, we will need to reduce the temperature, and this requires a global...
But imagine you've got one of those heat waves like they had in Athens, where it's 30 degrees at night. That starts to build up, right, inside a person's body, that over a series of a couple of days, it can survive maybe 2 nights like that, but a week, 2 weeks, it's really bad for people.
Absolutely, and it's not just the maximum temperature, because we normally associate the heat wave with these 40-odd degrees during the day. Actually, what's very important for the physiology of our body is the minimum temperature at night. So the fact that for a few days in a row you don't have that sort of cooling down at night is very problematic, and it's something that is particularly problematic in cities where you store this heat into the concrete, into the building, and you don't allow the minimum temperature to decrease. So this is something that we should be looking into in the future. Also because in some cities, and hopefully not necessarily in Europe for now, but especially in the wet tropics, we may reach a situation where it's basically impossible to survive outside without having air conditioning. So we got 34 point something wet bulb degrees wet bulb temperature, which is a measure that takes into account humidity and temperature.
And that's very hot in that.
Incredible. When you get to 36, basically that's it. Is game over. And this has been reached already in India. So in a sense, a situation where living outside without active cooling mechanism could become nearly impossible for some locations.
There are other changes underway which we don't see necessarily. You know about heat waves, you know about the extreme flooding, those kinds of weather events as well. But there are some other things that happen too, which I see in the data, which you can see in the Copernicus data every month. One of them is sea surface temperature. The surface temperature of the seas is incredibly high, and we have this graphic which I think gives you a great picture of what's happened longer term as well. Climate data is all about what long-term information. This is 1993 to 2023. Carlo, when I look at this, I'm struck by a lot of red, a lot of warming in sea surface temperature everywhere. Mediterranean is just entirely red. Look at the Black Sea. What's going on with this patch in blue over here? This is where you have El Nino, La Nina.
Yeah, that's right. So this is a region of high variability of temperature.
Right.
And it's probably, well, it's the largest player in terms of variability of temperature globally. El Nino, La Nina, you have El Nino, which is the warm phase, and during El Nino, we have just been through one. During the El Nino, you tend to have a peak in the global mean temperature, and you have La Nina phase, where actually a good part of the tropical Pacific is cooler than average, and so you tend not to have these large peaks. And depending on the sampling, you may actually sample one phase better than the other, and so this can have an impact.
So it's always basically changing all the time there.
It's changing all the time.
Natural variability, not necessarily a climate change related issue.
There is a bit of a tendency towards more of a La Nina kind of setting, but it's within a large variability that exists.
The other thing that strikes me is the blue blob. What's going on with the blue blob there?
Yeah, that's quite interesting. So, you know, you may think that we are sort of European biased because you look at this, it's close to home, and then you think, well, that's...
I guess it's close to home.
Right, yes. But actually, this spot here is probably one of the most important spots for the ocean circulation worldwide. So this is one of the most important places where the surface water actually sinks and drives a circulation that goes underneath all the ocean and redistribute heat from the tropics to the extratropics. This mechanism is to some extent, well, to a good extent, controlled by the density of the upper water, which in itself is controlled by the amount of fresh water coming from the glacier.
Because fresh water has a different density?
That's correct.
Okay.
Fresh water has a different density. So in a sense, for the ocean, for the atmosphere, density is mostly controlled by temperature. When you look at the ocean, actually you have two factors. You have salinity and temperature. Right. So in a sense, when you have very salty and cold water, this sinks. Increasing the temperature actually increases the stratification of the North Atlantic, meaning that it makes more difficult for this blob of cold water to form, and this has an impact.
So actually, this blue blob is a very good thing, and if we would like to carry on having the climate we've got in Europe, we need to have that filling up with salty cold water.
To some extent, yes.
And is there any sign? Because people talk about this kind of this heat pump from here up towards Europe kind of fading away because of the Arctic melt. Is there any evidence of that we see?
Yes, there is evidence. And actually over the last 2 years, there's been several papers being published suggesting, well, sorry, let's do a step back. We do know that this mechanism of circulation in the past has reached a halt, stopped. And so or slowed down very significantly to almost a stop. And just to give you an idea, this is of the order of 20 Svedrup. Okay, this is not a bad word. I'm not cursing you. A Svedrup is 1 million cubic meter per second.
Right.
Just to give you an idea, if you put together all the rivers of the world, you do 1 Svedrup.
Right.
You're talking about 20.
Right.
So it's a huge amount of water.
That's sinking down.
Well, it's sinking down and circulating, and then there is a return current at the surface. But it's a global mechanism. So if we stop this, we stop a big heat machine that exchange energy between the two. Now, given that this is to a large extent driven by this formation of deep water up here in the North Atlantic, and this is controlled by the density, having this fresh water up here actually prevents that formation, and this slow down the circulation.
Yeah.
If you slow down the circulation, we have seen this slowing down over the last few years, then it's possible that you can reach a halt. And the evidence that is emerging in these recent years is that this may happen sooner than we thought.
And so it would actually get colder in Northern Europe?
Yes, so this is one mechanism. There are other mechanisms for this circulation, especially that the surface circulation is also driven by wind. So the element of the circulation driven by wind won't change that much. But yes, the general element that has been brought up by these papers and then by the press is the fact that shooting down the Atlantic Meridional Overturning Circulation, AMOC in acronym, will reduce the amount of warm water getting into Northern Europe, which may have very significant consequences locally for Northern Europe with decrease in temperature.
Which leads me to, if that lost you because it's complicated, get this question that we had, which is, does that mean that Scotland's going to have a decent ski season?
Well, possibly, but it's not something that we do expect to happen very soon.
Right, okay.
So in the IPCC, we thought this is a possibility, but not particularly likely. As any field of science, the balance between evidence changes all the time. So this new paper may actually have increased our understanding of the fact that this may happen within this century.
Another question that we've had, I mean, we've got great ocean questions coming in. Thank you for those. This one's from Marianne. There have been great white shark sightings in the Mediterranean. Yeah. Will there be more of these as climate cycles shift? Because I would imagine great whites living around here somewhere. What are they doing up there?
Well, this is I don't have probably the information to answer this question fully, but it's clear that the rising temperature of the ocean are changing the biome, changing the ecosystem. We see invasive species coming in the ocean. I mean, personal experience this summer in Greece during the heat wave. I was there and I went snorkeling and I saw this lionfish, tropical and very poisonous fish. And this wasn't in the Mediterranean at all.
And they've come through the Suez Canal, and now they're finding the weather's better. Well, the water temperature is good for them, and they're staying there.
It looks like. So I assume that the same might happen for other species. I don't know about the white shark.
Okay, well, thank you for that question. We'll carry on. We'll look out for that one. We'll try and investigate it on Euronews.com. Sea level rise is something else I wanted to talk about. We've been measuring that well with satellites. They spin around the Earth every 16 times a day or something, and they're measuring and getting an average. That's how you do it. Very clever business. Anyway, the headline is sea level rise is at plus 4.3 millimeters per year, basically since we were at university in 1993-ish, more or less. 10 centimeters of rise since then, which is significant, right? It's measurable, you can imagine it. What impact is it having? Because that's accelerating too, isn't it?
Well, and I think that's why we need to pay attention as a society, because you'd read 2 millimeters and you say, well, it's small.
Yeah.
Who cares about 2 millimeters?
Yeah, when I started my job as a science journalist, it was 2.3 was the number we were supposed to give. Now it's 4.3.
Yeah, exactly. But still, you think, well, it's not that significant.
Yeah.
But as you say, since we were at uni, then it's 10 centimeters. And this actually matters. It matters in a number of ways. First of all, if you look at the coastal communities, so 10 centimeters, it means that for the same kind of storm and the storm surge that is generated, you actually have increased the risk of flooding, or coastal flooding, which means erosion, which means infrastructure like the railway in southwest England that is bashed every year during the winter storms.
Exactly,
so this kind of event will become more, will affect more the local community because of that. The second element is that this is happening, the sea level rise is happening largely because the temperature of the ocean is going up. So in a sense, this is an indirect impact of this. On the
but also because of the melting ice, right, as well?
Absolutely. Yeah. Now it's almost in equal part, the two.
Yeah, we've lost an awful lot of ice from glaciers.
And it's not the one on the water that matters.
So this is a very important point. Go on to explain the important point.
Because I mean, we talk about ice loss, and we clearly are losing a significant amount of sea ice as well, and in the Arctic, and recently also in the Antarctica. But for sea level, floating ice counts 0 because it's floating, and so for Archimedes' principle is basically averaged to 0. What really matters is the melting of the ice over land. So what's happening to Greenland, what's happening to the Alps, what's happening to the other glaciers around the world, Antarctica included, because this actually adds new water into the system, which increase the level of the ocean. And we know that if Greenland or West Antarctica ice sheet were to go, the sea level will be massive. So it's not just the
meters and meters.
Tens of meters.
Right.
I think it's 43 for Greenland or in that order. Don't quote me on that exactly because I don't remember.
No, but
the
it's
figure,
scary.
But it's in the tens.
But that's not going to happen just rapidly or in a couple of years.
No. It's a long-term commitment. But in a sense, the question is, this is one of the tipping points we discuss about. Have we reached the point where actually the melting of the glaciers is irreversible on the scale of the next few centuries? So we know that we are committed to these tens of meters of sea level rise in the next few centuries. The second element may be worth mentioning when we talk about sea level rise is the fact that it's really relentless. So we talk about the 1.5 and we see, okay, if we put our act together, we may still have a small chance of reaching 1.5 by the end of the century. Well, for sea level, we cannot change the tendency this century, and the sea level will continue to rise for the next 2, 3, 4 centuries. So it's not even a problem of the generation of our kids or our grandchildren. We're talking about several generations down the line. And still, our action today matters in terms of deciding what is the world that they will face.
So whatever happens in Baku this week, for example, sea level rise carries on.
Absolutely.
And there's nothing we can do about it. We'll just get ready.
What we can do now will have an impact down the line. So it's a matter of time.
400 years down the line.
Yes.
It's and I remember reading the WMO's report, the World Meteorological Organization's report about the CO2 concentrations in the atmosphere, and that the last time we had that much CO2 in the atmosphere, millions of years ago, the sea level was about 10 or 20 meters higher than it is now. So yeah, it's a scary prospect, and certainly the WMO was stressing that a lot in their press conference last week about this acceleration in the sea level rise.
And the other element maybe worth highlighting is just how gigantic these numbers are.
Yeah.
So since we were born in the 70s, well, in Europe we lost 850 cubic kilometers of ice.
Massive amount of ice.
It's just an incredible amount of ice.
Why is all of this happening? So this is all happening because of greenhouse gas emissions into the atmosphere, because of CO2 principally. It's the one that we talk about a lot, but also methane, other gases as well. That's water vapor though. But, you know, this is TV and we have to show you something. CO2 is invisible. This is a methane flare. I'm hoping at least it is. Basically, when it comes to reducing the emissions here in Europe, we're pretty much on track. Not perfect, but we're sort of moving towards our goal. We want to be climate neutral by 2050. And we've got goals for 2030, for 2040. We're doing it slowly. But every ton of CO2 makes a difference, I guess.
Well, in a sense, if you look at the plot of the sea level of the increase in the concentration of greenhouse gases, it continues. We have been through 29 conference of the parties of UNFCCC, and if you look at the concentration of greenhouse gases, you don't see necessarily an effect.
Let's switch over to that graphic as well, the one that you're talking about on greenhouse gas or CO2 concentrations, 2003-2022.
Well, that's what I mean. So Paris is more or less here, right?
Right. In 2015?
Yeah.
Okay. Yes, you're right. We were about 400 parts per million. The Buontempo Accords were signed.
And in a sense, this is what happened since. So in a sense, you're right. There's been a lot of movement, especially in Europe, but not only in Europe, in terms of pledges, in terms of plans. And some countries are really doing their homework. In general, I think we are really putting an effort. Nevertheless, what the climate responds to are not our promises. What the climate responds to is the concentration of greenhouse gases in the atmosphere. And the concentration has continued going up.
Yep.
So in a sense...
well, the climate, so it doesn't matter to the climate whether the gas was emitted in Berlin, Baku or Beijing. No, it's just going to carry on warming up.
That's absolutely correct. It's well mixed as a gas. CO2. And because of that, we cannot expect a different trajectory. So at times, journalists like yourself ask me, are you surprised? Well, no, not really. I'm not surprised the temperature is going up, because the fundamental cause, the fundamental driver of this heating up of the system is the concentration of greenhouse gases, which has steadily gone up.
And the emissions are actually gone up as well. That's the latest information we have. They've actually gone up this year. So we're continuing to fill up the atmosphere with more and more. You kind of imagine the atmosphere being huge. When you talk to astronauts, the first thing they tell you is how small it is. It's extraordinary, though, isn't it, that mankind in such a short amount of time has managed to make such a big difference?
Yes, it's extraordinary. Especially more extraordinarily, there was this picture in my room when I was growing up, the Earth rising, the one taken from the Apollo mission from the moon, where you see, probably is the most important picture ever taken.
The first time that mankind ever saw itself from space.
That's right. And you see that tiny little blue envelope around the planet. and that's all we have.
Yeah.
Not just on this planet, but as far as we know, in the solar system.
That's it.
And that's it.
Which brings me to a question from Sophie. Thank you for sending this one. Again, why is climate change so politicized?
Yeah, that's a very good question. And to me, has to do with the size of the challenge. So in a sense, the first global challenge we faced probably has been ozone, or the ozone hole. The ozone hole, we couldn't believe that it was like the spray and the deodorant that were making, or the refrigerator making.
It was hard to believe that your action at home somewhere would do that.
But we learned that was the case. And then we put together a global community who managed to find a solution, and that was a relatively quick fix. So you find a different industrial product or process, you change the industrial process, and you sort of solve the problem. We haven't solved yet the ozone hole, but it's sort of slowly recovering.
It's mending.
Yeah, exactly. It's an amend. Now, if you look at climate change, we need the same kind of resolve, the same kind of international agreement, with the difference that what underpins the problem is not one specific chemical in an industrial process, is our system of development, is our industry work, is how we built all that we see over the last 200-300 years. So clearly, the solution is much more complex.
It's huge.
It's huge. It's gigantic. It's probably the biggest challenge humankind has ever faced.
Yeah.
So in that sense, I can understand why it's political, because it forces us to rethink everything.
Right. Yeah. Why wouldn't it be political, I suppose, as you say, because it challenges absolutely everything about us. Let's talk about the action that people should take to adapt, what they can do to try and adapt, mitigate as well, to reduce their emissions. But just tell me quickly about some of the Copernicus tools that you've got that help people to understand at least what's going on with climate change, where they are.
Yeah, no, I think that's a very first step. I don't think we can adapt or mitigate without actually being aware of where we are. So the first element for me is to make the information available freely and openly, so that everyone can touch the data and interact with the data. But the data is difficult. The data is complex, and you may need a degree at university to understand it. So in a sense, something we have done within Copernicus has been to put together interfaces that make it tangible to each and every one of us. So one of these is Climate Pulse, as you were mentioning, that gives you the anomaly in terms of global mean temperature or sea surface temperature today. It's not
yeah, you can. I play around with it sometimes. I'll be thinking to myself, it's been a bit warm the last couple of days. Right. Have a look on Climate Pulse, try and zoom in on the bit of France that I live in, and I can see, okay, we had an anomaly of 2 degrees or 3 degrees or 2.5 degrees or whatever.
Yeah.
You can actually zoom in on that detail, can't you?
Yes, exactly. Also because this is an observed data, so it's based on observation. It's based on this million of observations that we receive every day. So you can really zoom in and see how the anomaly was around your house, your backyard, and precipitation in terms of temperature and so on and so forth. The second element, still on this visualizing and making tangible what we have, is to look at what might happen in the future. And so even there, we worked starting from what the IPCC have done with the Climate Atlas. We actually operationalize those Climate Atlas. The Copernicus Climate Atlas are available. And once more, you can zoom in your region and see how the temperature is projected to increase.
Right. So what's it gonna be like, not tomorrow, but 10 years down the line or whatever? What should I get ready for?
You want to buy a house?
Yeah.
Where should I buy my house?
Gosh.
That's kind of question I think as a society we'll need to ask ourselves more often.
Well, I was interviewing a lot of mayors last week at COP, because regional leaders, they're under the spotlight, but they're also the ones who are taking a lot of decisions, operationalizing some of the decisions taken here at Brussels at a national level. They were saying when it comes to climate change, they often don't talk about climate change to the local people. They talk to them about adaptation to heat waves, or to dealing with floods, or to rolling out bike paths, electric cars, whatever, things they can do to reduce emissions, changing food, for example, in the canteens at school, with other arguments as well, that actually talking about climate change can be a bit scary for people, and that making it concrete and saying, actually, we need to change the way we're doing our farming, or maybe you should be driving an electric vehicle or riding your bike, or switching to a power provider that's using renewables or something. It's sort of like, this makes sense, it's economic, and it's sort of tangible. Right?
Absolutely. Also because it's not that all of a sudden you start to do climate change policies.
No.
You have decisions that are based on what the market is doing, on what your competitors are doing, what's happening in your county. So there are so many other factors affecting your decision. What, in a sense, is the change in mindset I'm suggesting we should do, is to say, among all these factors, we need also to factor in the fact that the climate is changing, and we cannot just look back and think that we are in the climate of our youth, right? It's completely different. You know, the risk you were talking about, the Valencia before, we have seen the heat waves and sea level rise. All these things are modulating our risk profile significantly, and we should be our aim should be to learn how to use this information to be better prepared. So ultimately, it can be a tactical and a strategic advantage for us to use this information cleverly, more cleverly than we've done so far.
Yeah, to be smart and take action on it, as you're saying. Very, very specific things. Ask the right questions, look out for the data, and in fact, then you can find smart solutions. Carlo Buontempo, fantastic talking to you. Thanks for explaining many of the different questions that we had about climate change. Please head over to euronews.com/climate now to see reports about how our planet is changing, some of the mitigation, adaptation things that are going on around Europe, different projects and different initiatives. And also head over to euronews.com for full coverage of the COP29 conference in Azerbaijan. Our team is there. They're also blogging, they're live blogging, covering it, the politics, the decisions, the science. So please follow us wherever you get your news, on Euronews or euronews.com. I'll see you soon.